Well, good afternoon, everyone. Nice to see you again all here. My name is Fabricio Moreno, and I'm going to show you a resume of my doctoral research, which has been supported by Popular Autonomous University of the state of Puebla in Mexico and Brugge Universiteit Brussels here in Belgium. Firstly, we look what is the scope and research problem. Next, I will discuss how the research structure is. Then we see what are the advanced, and finally, we have a Q&A section. Well, let's jump right in. Well, as you know, a supply chain is the network or organizations, people, activities, information, and all kind of resources necessary for moving a product or service from supply to customer. It encompasses all the steps required to create and deliver a product or service, including procurement, production, planning, and control, inventory management, warehousing, and distribution. Supply chain management works to guarantee delivery at the most economical cost while fulfilling customers and consumer needs to increase customer satisfaction. As you can see in the slide, it shows the structure of a classic maritime supply chain. We can see that this chain is integrated not only by different maritime participants, but also economic phenomena such as economic upscales and levels of integrations. As you know, those multiple echelons, which is structures in this chain, turns on a complex one, which receive a disruption. That's the importance of to take into account this type of disruptive phenomena. A supply chain disruption is any event that causes a big bottleneck in the production, sales, disruptions of products. Supply chain disruption can include events such as natural disaster, regional conflicts, and pandemics. As you can see in the slide, disruptions are pretty common, more than one could think, and I think more than ever in this time. The impact of a disruption in a maritime supply chain is more aggressive than in other types of chains, simply because more than 80% of the world's commerce is actually transported by the seas. As you can see, the slide presents some of the typical disruption that we see since 28. You can see in other types during 2020 and 21. Additionally, one of the most dramatic upheavals in supply chains was due to the gigantic ship called Evergreen, which got stuck in the middle of the Suez Canal. You can see in the year 2021. In fact, some researchers, as Lund et al. In his research of 2020, find that supply chain disruption lasting a month or longer occur every 3.7 years on average. Indeed, many companies in the world don't know what are their resilience levels. And that's too bad, because if they had that knowledge, if they had that knowledge, they would have been better prepared and positioned to face a disruption, even preemptive. Delaying or deferring is no longer an option during a disruptional event. There is a great and tremendous opportunity ahead of us to truly transform our supply chain, not just for optimal operations, but in the moment of disruptions. That's one of the reasons we took this research theme. One of the best concepts to analyze the disruptional phenomenon is the concept of resilience. Oh, I don't know if it's correct, the pronunciation, resilience or resilience. Well, this concept traces its roots back to the work of Dr. Hulin, an ecologist who first noted the feature of the resilience ecological system in 1973. Since then, the notion of resilience has been applied to fields as diverse as psychology, systems thinking, disaster management, and more recently, supply chain management. Supply chain resilience is the ability of a supply chain to both resist disruption and recover operational capability after disruption occurs. As mentioned above, here as mentioned, the aforementioned that I said, viewing from this perspective, resilience consists of two critical but complementary system components. The capacity for resistance, as you can see, is contained in these two ingredients in the slide, avoidance and containment, and the capacity of recovery, which is structured in stabilization and return. Okay. In this regard, my proposal research is to analyze the behavior of the resilience of supply chain, taking into account and at the same time the most structural effect of supply chain. I mean, the synchronicity, the spillover, the bullwhip effect and ripple effect, and economic cost. The proposal perspective is that all these effects occur at the same time, emulating the effect named superposition, which is one of the classic phenomena into the quantum mechanics. Next, I'm going to describe in general scope every type of this effect. Well, what is the synchronicity? It's one of the complex phenomena that we can see nowadays. Synchronization occurs when the intrinsic times of the single objects become related. Synchronization implies that the states of two or more interacting agents with different initial conditions gradually approach each other as the time increases. Synchronization is an important method to reduce the negative impacts of uncertainties and disturbance of the supply chain. In this slide, in the slide, you can see an example of how the different nodes into a network try to approach their interactions at unison. That's the synchronicity in a supply chain network. Well, the next effect is the spillover. What is the spillover? There are activities generated by agents or institutions that generate profit without remuneration or even compensation, and that in the end are taken advantage of by an entire society at large. Spillover refers to the uncompensated impact that one process has on another processes, and that initially that was not its main objective. As an example of this spillover is, by my perspective, is very clear and didactic, is that the definition that put Blitzer et al. In the research in 2014, in which they equate this spillover to the process of pollination of insects. The initial and only object of insects in a culture is to eat and survive. And as they go through this process without realizing it, they themselves are pollinating with their body to the whole area of whatever crop that in the end will help the multiplication and said crop, becoming thus in a virtuous circle for all. In this regard, an example of spillover in maritime supply chain will be the unexpected benefit of a sustainable system in vessels, such as the enhancing of a capital in maritime ports. The bullwhip effect and the ripple effect are probably the most well-known and research effect when occur a disruption within supply chain. The ripple effect occurs when a disruption, rather than remaining localized or being contained to one part of the supply chain, cascades downstream and impacts to the performance of the supply chain. This impact may include lower revenues, delivery delays, loss of markets, loss of market share and reputation, and stock return decrease. The cost of all of which could be devastating. That is the principal characteristic of bullwhip, of the ripple effect. Ripple effect considers that the disruption and recovery changes supply chain structural dynamic, impacts operations, execution, and affects sales, service levels, and cost. The bullwhip effect, on the other hand, consists about the demand information distortion due to the inconsistency in the supply chain. It's a phenomenon where sudden spikes in demand are amplified upstreams in the supply chain, from the consumer to the retailer, to the distributor, and then to the producer, which then has to increase production for the demand that turned out to be phantom That's the bullwhip effect. The bullwhip effect is now to cause great inefficiencies and cost increase through excess inventory, lost revenue, and superfluous capacity, and poor customer service. Well, and finally, the last effect, economic cost. Some studies have found evidence that disruption to the supply chain following the onset of COVID-19 have significantly affected inflation. For example, in one research made by Benigno et al., I don't know, remember the year 2022, construct an index of global supply chain conditions and find that increase in global supply chain pressures contribute to inflation pressures in the United States. In the other research made by Celazon et al., I think the year is 2022, estimate that half of the rise in manufacturing producer price inflation for Eurozone can be attributed to supply constraints. Historical supply chain problems may have also affected inflation in prior years. That's the reason we apply macroeconomic factors such as inflation into the resilience of supply chain. In this slide, we can see the proposal of research methodology, starting from literature review and previous statistic analysis of our database. We firstly identified the different parts of the resilience of supply chains. As you can see, it is structured in the four states that we see in the beginning of these presentations. It's avoidance, containment, stabilization, and return. Once we got this identification phase, we continue to apply this superposition scope on all these aforementioned effects, which are the component of the resilience function. Then, with the obtained results of this behavior, we can measure, forecast, and optimize the resilient supply chain, and additionally making sensitivity analysis on different scenarios. The proposal of mathematical model is based on a Cobb-Douglas structure. That is to say, a function that is applied to describe how much output two or more input into a production process make, with capital and labor being the typical input described. But in our function, we make to put as inputs the 5 effects that I aforementioned at the beginning of this presentation. The feature of quantum mechanics in this function, I mean the superpositions, is represented by the sum of all alphas in this equation. That is the equal or 1. This issue represents not only a perfect proportions change between input and outputs, but also those effects take place at the same time. Additionally, the resilience behavior, which is obtained from all those 5 effects, needs to be applied in practical scenarios on maritime supply chain. Therefore, we deal with two kinds of issues. On one hand, we transform in well-defined values of the most iconic decisions from strategic management with focus on maritime port system. And on the other hand, we try to relate those values with the aforementioned resilience behavior. As you can see in the slide, we apply the structural equation model in order to obtain these values. I use the software called AMOS. It's part of the SPSS. IBM is very well known, this software. And then in order to concretize this relationship between the strategic decision and resilience behavior, we apply game theory, trying to obtain the Nash equilibrium whereby echelons are satisfied with their decisions. And the results are pending. As you see, we are working on it. And once the results are obtained, we can design both paths to improve the resilience in maritime supply chains and better strategies to implement during a disruptional events. The aforementioned results will represent new endeavors to enhance the resilience in chaotic events, improving the fulfillments and handoff during disruptions in a seamless manner. Well, that's all. Thank you for your attention. Please be my guest with your questions and answers.
Thank you. Thank you, Fabricio. I think it was a great talk, very straight to the point, and summarized your research proposal. So I wonder if someone has a question. I have a couple of questions, but I want the people from the audience to ask first.
I have a small question, because Fabricio mentioned chaotic systems. Which arguments you use to prove that this is a chaotic system?
Yeah. Well, it's a good question. When a disruptional event occurs during the time, it's a phenomenon which rise upheavals in whatever types. These upheavals will be a earthquake or a bottleneck like at the Suez like Canal of Suez, and that starts an explosion in multiple manners that even with strong supply chains could not put all this situation in control, and then start the chaotic features in a network. And that's the point that many research accord that the synchronization is the ideal ingredient to put the resilience in a control, because synchronizations deal in a well manner with the chaotic systems. That's my
that's
answer.
very interesting. It's very interesting. Thank you very much for your answer. If you already had the research, could you please share studies maybe in our chat about connection and correlation between synchronization and chaotic systems? I would be really very, very happy if it's possible.
Oh, sure, sure. In a few minutes, I will send you in chat.
Thank you very much.
Any other question?
Hi, very interesting presentation. I wonder about why would you use two models? And I mean, for comparison, to see which fit the phenomena the best, to predict a particular or repredict a particular case. Why making two models? I think I lost this a bit.
Yeah. Yeah, good question. Let me put in this slide. Well, firstly, in this model, as you can see, is the principal model. I use panel data. I use panel data applying generalized square method in order to make a regression. And obviously, by first hand, I need to apply unit roots, co-integrations, and as various statistical batteries. And then this is by the first method, and by the structural equation model, I use the ordinary squared method. And well, in this step of my investigation, I apply the two kinds of game theories, the Stackelberg form and the Bayesian-Nash game. And finally, I think we will need to apply a simulation in order to put in strategical and practical sense all these type of strategies in the maritime supply chains. I will apply the software named AnyLogic. That's the intention, and that's my answer.
Thank you, thank you.
More questions? Or I have a question, Fabricio.
Yeah.
A few questions, but first I was wondering if you use the concept of synchronicity and synchronization as if they are the same, or you make a distinction between them?
No, it's the same. It's the same. Probably I need to unify it in one word, but it's the same.
It would be good to take a look more in detail to the meaning of those, because as far as I know, there are some differences between synchronicity and synchronization. Synchronicity, for example, belongs to quantum theory, and synchronization is not so central to it. Synchronization is more like from complex systems, and synchronicity is more for quantum systems. So I think it would be good to take a small review or find the connections, because there are connections for sure, but
okay. Well,
but these two concepts have some some differences. And
Okay.
this, yeah, might be, yeah. So another question I had is like, is this one about your approach to resilience is based on these 4 dimensions. Can you please show the flow diagram where you explain your research project?
Certainly.
Please. Yeah. So 5, sorry, synchronicity or synchronization. We will see spillover, which is if I understand correctly, spillover is like the unexpected effects of the actions, no?
That's right.
So, but this could be positive or negative, right?
Exactly.
And then the bullwhip, I didn't understood it well. I was trying to get it better here, checking on Wikipedia, but it's a sort of propagation of the demand in different levels of the supply chain, no?
Yeah, exactly.
So if the consumers want more iPhone, at one moment we see an increase in the request for iPhones, then that increase goes to the producers, which instead goes to the manufacturers, and so on, and the demand goes in amplification.
Yeah, exactly.
Is that the case? Yeah.
Yeah.
And then ripple, this one I didn't get. What ripple means?
Yeah, it's like in this slide, the ripple effect is where the disruption take place. All the negative factors cascades downstream and impacts all the performance into the supply chain, and in a very and rapidly way, and that's the ripple ripple effect. Ripple effect analyze that disruption and recovery action change supply chain structural dynamics, and that's the principal feature of this ripple effect.
I see. So what's the difference between the ripple effect and the other effects? So I'm just conceptually trying to understand how different they are.
Okay. Well, the principal difference between bullwhip and ripple effect is almost subtle, because in the bullwhip effect, the graphic that in your right hand is as you can see, is a distortion between what really is the intention of the demand from the customer, and by the distortion of during all the supply chains, and by the deterioration and poorly speedy way about the information, in every echelon receives in an incorrect way, in an incorrect information, and then in the factory is when it explodes the phantom information. But it's, as you can see, is a distortion information in the bullwhip effect. But in the ripple effect, it's not only distortion information. It's additionally effect, physical and tangible and intangible.
Yeah,
that's the principal difference.
Yeah, very interesting. I think we should have to, as I'm just giving a little advice here on everybody's present, but I'll say it now. I think it would be good that we go a little bit more on detail on explaining this, like the similarities and differences of this, perhaps in a specific study case, imaginary study case, where we can just, you know, maybe make in one page, explain, like, assume that this is happening and this blah, blah, blah. So this is ripple, this is that. And so it gets really clearly explained in a simple way. And the other now, okay, I end with the concepts. And now I go to the other domain, which is what others have been doing. Why, the question is why this research is novel? What is in this model of resilience, which is not in the traditional planning of ports? Because of course they know it's a lot of money there, so they probably think a lot on how to optimize and so on. So I could not completely understand what is done already by ports and what is new from what you propose.
Okay.
So,
well, first of all, I only use Wilbep and ripple effect only to catch this effect when the resilience occurs. My intention is not provide a new perspective on this type of effects. Only I use these effects into an equation in order to represent the resilience as a structural phenomenon which occur the 5 effects at the same time.
mm-hmm. Yeah, I don't know the details of the formula, but then so we can go on more detail on that. I understand. So R here is the resilience, and it's a function of S.
As is the synchronicity.
Yeah,
yeah.
P is the
spillover.
Spillover, B is the bullwhip effect, D is the
ripple effect,
ripple, and
the last one is economic cost.
Is economic cost. Okay. Yeah, and do we expect, go back to the formula, please. So we expect that F is increasing with respect to S. So if I have more synchronicity, I have more resilience.
Yeah, that's right.
Then if you have more spillover, then you have more resilience as well,
yeah,
no?
But in a positive spillover.
Positive spillover, because it can be positive or negative.
Yeah,
then the bullwhip effect.
Because it's spreading, I think.
Yeah. The bullwhip effect is a negative effect to the production. So it's decreasing with respect to the bullwhip. The more bullwhip effect we have, the least resilient the system will be, right?
Exactly.
So, and then with respect to the D variable, which is the ripple effect.
Yep.
It's again.
Exactly.
Because the ripple effect is the negative effect in the end. We expect it to be the propagation of bad things, right? Where and then the economic cost, of course, the least cost, the more resilient. Yeah.
Yeah, exactly.
And then this last variable lambda, what is that? E to the power of lambda?
Well, it represents the lambda in an exponential way. It's like the interceptor in a regression.
Okay.
But when you transform in a logarithmical way, lambda converts in a interception, and then
okay, but then you are thinking of a linear function then.
Exactly.
And that's why you have these coefficients alpha equal to 1. So it's a convex combination forming a linear function.
Yes, exactly.
And then alpha will be the relative weight, the relative impact on resilience of each of these variables.
Yes, and with the intention that if all these 5 effects occurs at the same time, then their alphas equals to 1. That's my intention in this model.
Yeah. You want to make it compatible with all the effects having some like, happening to some extent. And then the measurement of these 5 variables will depend on the case of study you make, right? You will make a case of study, and then you will make a specific model of what is the value of S, what is the value of P, of B, D, C, right?
Yeah, in every effect, my intention is to apply the advanced models that already exist by research.
Okay. There are models for the mathematical shape of these variables.
Exactly.
And then you will make a combination
Exactly.
of all of those. Yeah. And okay, so here it comes like the question that you will get maybe in your PhD defense. So this linear model, it's the first approach that assumes that all these variables are independent, right? That's why you make a linear function. You assume that changing in one will not make any change in the other. That's but what happens to the interferences between these variables? So if you have too much spillover, then I don't know, something like a bullwhip effect could also be changed or something like that. You see what I mean?
Yeah.
That these
You mean
variables
weights?
might
You mean
not
weights
be.
in the
Hmm?
You mean weights in linear function, so that every variable of these 5 dimensions can have its own weight.
These are the alphas. The alphas are the weights. So
Yeah, but
actually, let me draw the function as it is. R, according to this model, is actually alpha 1 S plus alpha 2. Do you see what I'm writing? P.
Yeah.
Plus,
I got it.
And then plus alpha 5 C plus e to the power of lambda, or minus e to the power of lambda, but okay, plus. So this is the function, and he's defining it in this simplified way because f, it's assumed to be linear. By linear, it means that it's the product between a constant and the variable, and then plus constant and variable, plus constant and variable. But what happens with these effects that depend on the product between S and P, or maybe the product between B and C? The non-linear terms, these are non-linear because they depend on the product of the variables and not just the variable with a constant.
Yeah, in this case that you apply, that it's fairly put in this way. In this case, could happen. We could apply some other kind of techniques which are ideally applied in the regression model. This kind of correlation between these variables, such as the generalized least squared, which work very effectively when this type of correlations occurs. And if this case happens, we can modelize with a high significant way this representation of this resilience function. It's only a matter of to use technical regression specific with this kind of correlation.
Yeah. No, it's clear. But the question is, of course, there will be methods, and we could go over that later. I just wanted to to make clear that this is the most the first way in which this should be done is the first order approximation, and then more generally you will probably receive questions later, people asking for nonlinear effects, because this is a complex system, so it's very likely that things separate so nicely. They are normally all intertwined, so but it's okay. And the last question I have is, how are we like the measurement of these variables, they exist in different scales. What are the units of measurement of spillover and all this?
Oh, yeah.
This is all research made by others, I guess, right?
Yeah, right.
Yeah. So let me just clarify for the last time. So there is research where they define R as a sorry, we'll start again. So there is research in which they define R as a function of S. Others define it as a function of P. Other defines it as a function of B, and so on. Or are there already guys that have made some of these combinations? What's the literature review? Because you are assuming that the system, the resilience depends on 5 variables. And you were saying that some guys have tried some of these variables only. So maybe some people try this 2, some other people try this 3, or some other people try this and that, and also that. What's the complexification of the formula so far? Because you're bringing a more complex, even more complex formula, but I don't know how complex are the other formulas. All of them are univariable, only defined by one variable, or they have already combined some variables in their models?
Yeah. Well, in the first effect, the synchronization, as well as the rest of the variables, my intention is to capture only a constant value in order to represent in a time series format. I think that I agree that the synchronization effects deals with a complex system, but at the final of the day, it captures a constant value, and it helped me to construct a time series format in order to make this equation in a regression way. And in literature review that I made, there are research that only put as an input in the resilience equations, put the bullwhip effect and ripple effect and some economic cost. But at this time, according with the literature review that I made, there are no research about put the synchronization and spillover besides the rest of the effects into one equation. And additionally, there are no research about if this resilience take the feature of the superposition, in where all these types of effect occur at the same time. Because as you can see, when occur a disruption, it only occurs in a specific part of the time. And before the disruption occur, the spillover is already occurring, as well as the bullwhip effect, even the ripple effect. And this equation represents that during all the time, no matter in where point of the time occurs the disruption, during all time, are occurring these 5 effects, it's in distinctive, excuse me, in distinctive ways, in distinctive distinctive intervals of values, but are occurring at the same time, and that's the way that I try to prove in this function.
Okay, great. Any other questions? Okay, so thanks again to Fabricio. We will then stop the recording and continue with the meeting.
Okay.
So thank you, Fabricio.
Thank you to all of you.